Hello everyone. In this video we are going to solve a worksheet of lecture 4. So let us start by the first question. We need to indicate the domain of definition of the function, then determine the intervals where each function is increasing or decreasing, and precise the nature of their externals. So if you look at this figure, the domain of definition is from, you can just count the digits or the boxes. So the domain of definition is from -3 till 2. Now we can see that at the point B, we have relative and absolute minimum, or local and absolute minimum, because it's the smallest value reached, so it's the absolute minimum. Also, at B, the graph decreased, then increased, so this is a relative minimum or local minimum. Also, we have at C an absolute maximum because it's the maximum value reached. Okay, let us go for the second one. In the second one, the interval is from -3 till 3. At the point B, we have relative and absolute minimum. At the point C, we have relative maximum. At the point D, we have relative minimum or local minimum, and the point E, we have absolute maximum. Now, and the third one, first of all, the interval is from -2 till 2. Then at A, we have absolute minimum. At B, we have relative maximum or local maximum. At the point C, we have relative minimum, and at the point D, we have absolute maximum. And now in question number 2, we need to set up the table of variation in each of the following cases. First of all, the domain is from -2 till 4. The graph increased, then decreased, then increased, then it becomes constant. So if you can see, this is the table of variation. We put the interval from -2 till 4, then it increased from -2 till 0, 3, then it decreased till 2, 0, then it increased till 3, 1, and then it continues constant till 4, 1. Now the second one, also the domain is from -2 till 2. So we have it increased, then decreased, then it continues increasing until it reached 2, 3. If you look at the third one, we have two parts of a function. That means at 0 it's not defined. If you can see, it didn't pass through 0. That means at 0 it's not defined. And everything before 0, the negative part, it's decreasing. Also the positive part, it's also decreasing. In the first one, it decreased from -2, 3. Then in the second one, it decreased till 3, -1. In question number 4, we are given a function x² minus 2x, and we need to calculate f of 1. Then to show that f admits an extremum at 1, and we need to know what's the nature of this extremum. First of all, what's f of 1? We just replace x by 1, so we get -1. And now to prove that, or to show that f admits an extremum, we do f of x minus f of 1. And we check if it's positive or negative. If it's positive, then it has a minimum. If it's negative, it has a maximum. So after calculating, we can see that we got a positive number, then f of x, it has a minimum, and to calculate it, we just replace by f of -1. Okay? Now, given the function g, also we need to calculate g of -2, and then to show that g admits an extremum at -2, and to tell what its nature. So first of all, we are going to calculate g of -2, which is 6. Now we do g of x minus g of -2. Okay, so it's x plus 2 squared minus x plus 2 squared, so it's negative in all cases, so it admits a maximum. Okay. In question number 5, we have two functions, f and g, over the interval minus 5, 3, and we need to determine graphically the set of the reals x such that gf is above g of t. So where's f above g? So g is above, our f is above g, it's from minus 5 till 4, union 0, 3. In the two intervals, f is above g. Now, where's f of x is equal to g of x? Or, in another word, what are the points of intersection of those two graphs? So the two graphs, they intersect at x equal to minus 4 and for x equals to 0. Now, when I say f of x less than g of x, I mean whereas f of x below g of x. So it's only between minus 4 and 0. In question number 6, we already have this table of variation, and we are asked to pick out from the table all these questions. So for the first one, what are the antecedents of 4 by f? So the antecedent has only one antecedent, which is 1. It's obvious from a graph. So when I ask about the antecedents, or I'm asking about the abscissa, or I'm asking about the x values, if y equals to 4. So from the table of variation, the only point where, if you can see it here, I'm going to locate it for you. In this point, we have y equals to 4 and x equals to 1. Now complete the following inequalities. F of 2, it's between minus 1 and 4, because f of 2 is here. I'm going to change the color, just wait a minute. F of 2 is here. Okay, so it's between f of minus 1 and f of 4. And now what's f of minus 1? F of minus 1, here it's between f of minus 5 or minus 5 and 1. You can choose the first value. Is there a number in the interval minus 9, minus 2? Minus 9, minus 2. Is there a number in the interval minus 9, minus 2 whose image is minus 4? Is it possible? Yes, because minus 4 belongs to minus 3, minus 5. So there exists a number in the interval minus 9, minus 2 that has an image minus 4. Now solve the inequality f of x minus 4 is less than minus 4. When I say f of x less than minus 4, I mean everything which is less than this part. So we are going to get alpha 0 union 3 plus infinity. Okay? Here we go to the last question, which is question number 7. We have the function defined by f of x equal x squared minus 2x. And we need to show that f is decreasing over minus 2, 1 and increasing over 1, 4. So if you still remember, how do we check? We just take any two values, x1 less than x2, and we replace f of x1 minus f of x2. If it's positive, then it's decreasing. If it's negative, then it's increasing, and so on. We proved that it's decreasing between minus 2 and 1, and it's increasing between 1 and 4. Show that minus 1 is the minimum of f. How do we calculate, or how do we prove that it has a minimum? We just do f of x minus f of minus 1. It should be positive to has a minimum. And how do we calculate its abscissa? We just replace minus 1, as I told you. So set up the table of variation. If you can see in number 3, we constructed the table of variation, which is we write first the interval from minus 2 till 4, and as we said, it decreased, then it increased. Now fill in the table. We are just going to replace x by minus 2 to find the y, so it's just replacing. So those are the values. Then now use to graphically, so after constructing this curve, f of x equal to 0 is for x equal to 0 or x equal to all of these. And number 6, we are going to pick them graphically from the graph.